Hello and welcome to Agent Engineering. Hope you guys had a good New Year's break and Happy New Year. Uh, so this is episode 6 of the live coding stream series where we are developing an agent framework from scratch in Go. Uh, Before we start today's stream, I had a couple of announcements that I wanted to make. So let me share my screen. Okay. So first of all, we've crossed 50 subscribers. So thank you everyone who is subscribed to this. The second announcement is that we also have we also have a Reddit subreddit for this particular project, which is engineering underscore dev. So if you want to chat with me about what this project is about and what we're going to do next, or if you have any questions, you can add it here. You can also add it in YouTube comments. So that is the uh, second announcement. Uh, before starting, I wanted to discuss one of the tweet that Andre made, and I think it captures the essence of what I'm trying to do in this series. So we started this project a month and a half back, and this recent tweet captures what I'm trying to do. So what it says is, I've never felt this much behind as a programmer. The profession is being dramatically refactored as bits contributed by programmers is increasingly sparse and between. I have a sense that it will be 10x if I properly string together what has become available over the last year or years. And the failure to claim the boost feels decidedly like a skill issue. So basically, there is this new AI technology, and with this, the programming landscape has changed. So there is a new programmable layer of abstractions to master. So this is exactly what we're building in this stream live. Like, uh, so uh, uh, this new programmable layer. So I think emphasis here on programmable, uh, because not one solution fits all, right? Uh, so in addition to the user layer involving agents, so what are the components of this layer of abstraction? Agents, sub-agents, their prompts, context, memory, modes, permissions, tools, plugins, skills, right? So referring to cloud skills, hooks. So this is already something that we're building in our agent, specific type of agent where we have where we're going to have hooks, pre and post session, MCP again. So in our stream, we'll integrate MCP but a bit later. LSP slash commands. Also, all these components form the new layer, right? And need to be built in an all-encompassing mental model for strengths and pitfalls of fundamentally stochastic, fallible, unintelligible, and changing entities suddenly intermingle with what used to be good old-fashioned engineering, right? So, and I think he captures the sentiment here. Clearly, some powerful alien tool has was handed around uh, uh, was handed out to us, and expect it comes with no manual, so we don't really know how all LLMs actually work, right? So we have to figure out how to use and operate it, right? While the resulting magnitude network is rocking the profession, so roll up your sleeves and not fall behind. So I think this is what the stream is about. So this discovering this new programmable layer is what we are doing for the last month and a half, and we'll be continuing with this. So with this said, I think it's a good way to segue into our stuff that we were doing. So just to refresh, what we were doing last stream was, so this is our custom agent loop, right? So if you see closely, it is like a normal loop, but agent loop. But what we are doing is we have a specific implementation where we are going to uh, added as a Git workflow in this loop, right? So whenever we init a session, we will create a branch, right? And so this is a common agent loop, right? Where we have a conversation history, we run inference for each message in the response. If it is text, we add to the history. If it is tool, we execute and add its result to the history, right? And if there are more tools, so we continue the inference, right? That means it's not over if it's not the final message. If it is a final message, we commit all and we create a PR, right? So this Git related stuff we are adding in our agent. So it's a departure from regular agents like Cloud Code, but we want this to be intentional, that our implementation is a Git based workflow. And the rationale behind this is that the work done by an agent, right? It is some work that needs to be revisioned, right? And Git is a way to do it. And any work done by it, right? Either it will be accepted or rejected, right? Based on the quality of it, given the instructions, right? The user might also say, okay, these instructions were not good and reject the whole thing. It needs to be revision. That's the first thing. And also it it requires tokens, right? It costs money, so we should not waste whatever it was generated. So best thing we can do is keep it in some branch. We decide to merge it or not, right? So that is the rationale behind this. And so last stream, so I think this is a good place we can jump back into implementation, right? So last stream we were trying to build this, and we did some stuff related to Git, and we will be continuing with this. Yep. So okay, right. Okay. So what we're doing here is when the agent is initialized, right? The init session, this particular session for an agent, given a goal provider, right? We have already supported this. Environment file is required for executing this from a different place by referencing this environment file, which has API token keys, right? Secret API keys. So what we do is immediately as soon as we start, we want to do git init, right? So if the repo is not initted, so what we do is initialize repo and initialize this object. So this will be our global object that we refer to in this whole session, right? So we do git init, and so there was some problem that we were facing in our branch, creating branches, right? So let's start there. Right. Actually, let's start by adding some logs in it, right? So if we can add some so if it already exists, right, we will say that the agent is saying found opened a Git repository, right? So this is one thing. If not, we will create, and here we say created and open a init and open a Git repository, right? Init. Is there double D? I think initted is not a word, so it's fine, right? So this is the thing that we want to do, right? So one more thing we have to do here is that we have to set a main branch, right? Because when we init a repository, it does not come up with a main branch, right? And for that we have to make a commit, right? So what we're going to do is so this is some Git that I have already created. Already looked up this documentation, so I have a reference. What we have to do is create a symbolic reference from head and plumbing. Let me refer to new branch. Right, so we'll create a new default branch, right? Then if to report art. So we need to store this reference. So we're creating a new head uh, on this branch name, and we are storing this. So what we have to do is get the work tree, return all the errors which can be printed, and the agent will exit. So we have to write a git file, git keep, right? So we write this git keep. In the working tree, we'll add this file called git keep, and then we have to make a commit. So the commit will be initial commit, right? We're initializing a repository, so we need an author for every commit, right? So let me just say, so author for any commit made by our will be agent framework, right? And we also need email. Okay, let's add framework at agent .tech, right? And when is time, so we make a commit here. So when we init something, we have to do all of this stuff, right? Comes here, and any error happening here, let's exit quickly. Let's not ignore errors, otherwise it will come to bite us later. Is hash which we can ignore an error. What does commit give? Again a hash. We don't need a hash. Right. So this is an update we have to make to our init folder. Sorry, init function, right? So this is done. So if the repo does not exist, if we started a session in some place where it is not, sorry, let me put this here for now. Give me a minute. See some. Okay, yeah. So what I was saying is we continue with our Git escapades, right? So this is create main branch, right? Make an initial commit. So this is fine. Right. So the next part we have to figure out is here. So this is done. So when we do a create branch, there are a couple of things we need to handle that we have not handled yet. So let's go into that. What we are doing here is, if it is nil, we return that, okay, this needs to be called, right? Then we take the working tree and we are doing the checkout on a branch, right? Create true, right? Okay, this looks like it should work. Right, what we have to do is actually, if the branch does not exist, we have to I mean, if the name exists, we have to handle the conflict, right? Right. Okay. Let's say if nil, then fmt println agent, right? Created branch given the branch name, right? So branch got created, and then we return. Else we have if string contain already exists, it's the error says that this branch already exists. So we can use a simple format of what do you say, adding a date time at the end. So let's take suffix time dot now current time, and then we can format it to get a date time, right? So this is to get the date and time. So this is just to d2 power. And the name becomes branch dash this, right? Then we can add some log saying that let's see if the stream is going well. Right. So we can add some log saying that created a new branch. We can actually say branch exists, and we created a new branch with a new name, right? This is not the name that was given to us in this, right? Then we do the same thing, branch created, right? And we return nil, except error, right? Here also here we have to return error, right? So because this error is something else than already created. Okay. Okay, this looks good. Right. Okay, yeah, right now. Right. So, okay. So we'll test all of this. I have a couple of things to do before we jump into a debug session. Right. So, the get init and create branch is done. Right. So these are pre-hooks for a session. Whenever we create a session, we always create a branch so that whatever work our agent has done, we can, review it, and then we can decide whether or not to merge. Right. So that is the reason why we are doing this. One thing I don't like is the fixed branch name, right? So last stream I said that should we make an inference here, right? So what I'm going to do is we have to make like a LLM inference, and this inference is not like the one we are doing here, right? Which does a run inference. This is the main interface used to talk to a couple of LLMs. And this is mainly for agentic loop because we give it messages, which is the conversation history and tools. So something we need now is a bit different with where we want to give it we want a structured output, right? So a structured output call to LLM is a bit different than tool calls, right? We want to give it a response schema that, okay, given this prompt, generate this JSON, right? So let's add that here, right? All right. So let's name it generate structured response, right? So what we need here is, let's keep messages, right? Okay, remove this, and what we're going to do is we accept a pointer, right, to the struct, to the type of response we want to create, right? And then we will just populate this and return back to our caller, right? So I'll tell you what I mean by this. Okay. So what here we are going to do is session init messages. Okay, I will do this. And we will say, so here we are doing an inference to get a dynamic branch, right? So we don't want hardcode branch. So we just ask LLM that given this goal, what should be our branch, right? So it's a bit, that makes it a bit clear like that, right? So what we have to tell is this, right? Give a message of role user type text, right? And the text should be, we say, given the goal below, right, give a name. So we'll also get the name of the session. So if you see how ChatGPT work is, when we submit, it automatically names our session, right? So we'll just ask for the name as well. So we say give the name below, give a name. I think in the session, and we need a name, and we need a branch name of the branch that needs to be created. Name of the branch that needs to be created in the record, right? And then we give given goal. You can just say this and add the user code. So just to get a branch name, we are doing all of this, right? We are making another inference with LLM. So we need to generate, it's a session init messages. There are no tools here, right? So now we need a struct for what kind of thing that I just added here. So its type is session init response. We want to name this session, let's say session metadata, right? We can add a lot of other things also here, right? So we need session name, it's a string. Let's add this JSON schema description, name of the session, and branch name. Okay, so this is why we have added here, right? So we say session metadata, and we pass a pointer to this guy. If there is error, we bail quickly. Let's not do log.fatal, it's not good. Okay, since this is main file for now, we can do log.fatal. Later we can clean it up with proper error handling. Log.fatal is a crash, so we don't ever want our program to crash. But for now it's fine. Okay, so this is the nature of this thing, right? What it's saying is that given this, create me a branch name, right? So what we can do is, when this is done, you can just say branch name. For now we will not use the session name, we can use someplace else, right? But I thought it's just good to piggy bank here. Right, now we need to implement this, right, in all our implementations, right? In all our LLM implementation. This looks good to me. Okay, let's start our implementation. So if you see this one, it will already start complaining that there is a missing function, right? For generate, let's add to the end of this, end all of this. There should be a better way to collapse all. Right, what we need to do is generate struct structured, what did we name it? Structured response now, right? It takes a response interface, So now and then again I keep checking the stream health to see if everything is going okay. I see a couple of people also joining. So if you have any questions or think, you can add it in the chat. Okay. Right. So we need to implement this, right? Let's go. So let's copy actually everything that we've done here because it should be mostly similar, right? Without the tools thing, right? We don't have tools. So we want to make in inference, but we don't have tools. What we have is response JSON schema, right? So this is what I was saying, that we can make two types of LLM calls. One, given tools, what to do. So it will give us either text or tools, right? Other type of LLM call we can make is given an input, give me a JSON output, right? And we have to tell what schema it is, right? So we will reuse our function that we have written for tools, right? Schema generate open a schema of type res. Right? So what this does is takes the instance of this. It does a reflection. It will see what fields this has, what description is, and it creates it into a JSON schema, which is required here, right? We also have to handle error. Error, we just return here and we pass schema. Right. So this is, oh, this is Google client. I thought we were doing it in, oh wait. Okay, my bad. I'm doing this in a wrong file. It should be OpenAI. Do the same thing. Right, let's, and here we need to do all of it. We need to copy this guy, not that guy. Right, everything else should be same. Right, we remove the tools. Delete this. Actually, let's remove this out. Call it params. Right, there are no more tools. Right, what we require is a JSON. So basically, Gemini, where I was editing the file, Gemini and this also had the same thing. So we have schema generate OpenAI schema given the response, right? Also handle error, return error, right? So this is how we instruct. Okay, there is another object here. OpenAI of JSON schema. Okay. Name, it requires name also. So we describe the schema, I guess, now. So let's just call it generate structured response, right? So this is the name of our JSON, right? The outward name. Sorry, the name of the schema. So this has strict, right? Actually, let's do strict so that it follows OpenAI bool true. And then what else is there? finally, we have also description, right? Description, what it says. Description. Okay, let's keep the description empty. Actually, it's anyway optional because there's nothing special here to describe. Schema, here we go. Right. We remove this. Okay. Then once we make the LLM inference, we go here. We don't want tool calls. We don't want all of this. Okay. Oh. If not equal, what we want to do is JSON unmarshal it to the struct, right? If it fails, we return error. Else, we default to returning nil, right? So this is the kind of function that we want here, right? Where we are making an inference to create a branch, right? I think this is a good time to see if our code that we wrote extensively is working before we get lost. But before we run it, because now it's going to fail saying we haven't implemented this for Google and Anthropic, right? So let's just create stubs. We say implement missing method and it panics saying implement me. Okay, so we have stubs ready. This should install properly. Right. So now a moment of truth. So we have our agent framework ready. So let's create another shell. So last stream I had discussed that we are going to use this for a project called chess tail, right? Let's create that project, cd chess tail, right? And okay, so this is the first run of our agent. Right? So what we're doing here is invoking our agent framework with provider OpenAI, whose implementation we have done, and we're giving the environment file required for secrets. What we will ask it is something like I prepared some question. Format. I had prepared some. Okay, but let me just repeat. So basically, okay, this is the first use of our agent. And for chess-tail, before going into the project, right, what as a agent user I want to know is what are the open formats required for chess, right? How boards are represented, how moves are represented, how games are represented, right? So I want to know that, and for that, actually let's change the our system prompt a little bit, right? Before we execute this, what we will say is because we want to see our branch getting created and all the stuff, right? So what we can say, so this is prompting. The goal can either be a question or instruction, right? If it's a question, append the answer to qa.md file. So for now, this is some crude construct that we eventually will evolve into memory, right? Agent memory. But for now, let's whatever our question answers we are asking the agent regarding a project, we will save it in a MD file, right? Right. Else follow the given instruction and write. Okay, let's just keep this simple for now, right? So whatever question we ask, what are the open format? Let's build again so that we have the latest code. Present, okay, okay. Okay, so this is a question. So our goal is kind of a question here. Let's run. So it says initiated a repository that created a branch. Okay, so branch creation is working, right? Now it is doing tool use. We had added file system tools to read file. It should be empty, right? So there's no file called this. So at least we know our branch creation is working. Seems like we'll start. Let's rename this. Okay, I think we have something here, right? So it did something, right? And it added it into our, it used the right file. So I think our agent is working here, and our first Git flow for the agent is, what I will do is I will open chestail and attach it here so that I can observe what is doing. So as you can see, there is a Git file created, and then there is a question answer, question being answered, right? So this is, as I said, is a crude way we'll do memory now. Later we'll explore different ways of doing a memory. For now, what I want to do is, like, for a given project, right? The developer starts with open-ended questions before narrowing down on what we want to build in chest here, right? So this is one of the questions. What are the formats that we have to use, right? So it's saying there is a pen format, there is a EDP format for board positions, and for game position there is PGN form. It has not given more detail into what those formats are, so that's kind of a bummer, because as a new person coming into this, I want the agent to tell me a bit more about it, right? Okay, anyways, good thing is our flow is working. Git flow. Later we will see with different models how this works. Okay, so that is the first order of business that we were going to do this stream. So the stream is titled token counting, which is what I want to get into now. It's too late to do that. So last stream, I think, if before going into token counting, one thing I have to fix is that last stream we went into an issue with Anthropic, where it was sending an instruction to create write a file without content, right? So I did some debugging offline, and it turns out, okay, we also have to do this. Okay, let's quickly do this. Okay, let's quickly do this so that we have everything here. Right. Let me just add it there. So for generate response for this guy. So one thing uh, before we go, I was saying that there was an issue with Anthropic, and the reason was because of max tokens, right? So the content was being sent, but it was a big more content than this 1,000 tokens. So the content was getting omitted when we were creating our JSON, and it was writing nothing to the file, right? So we have to handle why this was stopped, right? We have to handle stop reason and increase the token window size, max token allowed to be created, right? So for now, what we can just do is multiply this by 10 everywhere so that when we get into this issue, here it should be max completion token, max output tokens, and OpenAI max completion token. Actually, I don't know why I'm doing, because the tokens are counted per 1,000, right? I don't know why I'm doing this like it's byte, right? So let's keep 1,000. Right. So for now, the issue regarding this should not come up. Max token. What we have to do is we have to see if anthropic dot stop reason equal to, if it's stopped due to max token, we have to immediately throw error, right? Return nil, max token exceeded, right? So we have to do this everywhere so that at least when this happens, we know how to we know where to continue debugging, right? Give Google response dot, does this have stop token? Is it in candidates? Okay, finish reason, right? Okay, then it should be in between this. Yeah, finish reason is equal to string. What are the values here? Finish reason, max token, right? Dot max and return max token. Same for what it requires. It requires an OpenAI dot int. I don't know why it has its own type for int as well. I have to do it everywhere actually. If chat completion dot stop is choices, finish reason equal to, okay, what is it just now? Length. Okay, length if maximum token was reached. Okay, so here the value is length, then return error, max token exceeded, right? So actually this is true for, this is generate, right? I have to do this for run inference as well. Okay, so this solves the issue that we were facing last stream. And so before we move into token, this is one important thing to get out of the way. So let's continue with the generate for Anthropic and Gemini then we can move to code token counting. Okay. So one thing with Anthropic is that there is no response schema, right? So if we see it's this thing, there is no way to say create a response schema. I did some digging and it turns out that if we want to use that kind of feature which Gemini and OpenAI gives, that we have to use tool calls, right? So here there is no other way than saying creating a tool call, right? So here we have to construct a like a fake tool call. Okay, what I do? We have to construct a fake tool call. Name should be generate structure response. Description is given the goal. Actually, given the goal, so the goal will be in the messages, right? Generate which is response, right? So this is a generic tool call. Input schema instance should be, we can just pass it along, right? So this is a way to hijack what else is there. So there's no function implementation, we don't really need this. All right. So we did this, right? We made the LLM call, right? So here it should only be tool use, right? The response should only be tool use, because actually we can say force a tool choice here, right? So that would be equal of tool. So we can say force this, right? Tool choice, copy tool choice parameter. Right, okay, just name it, right? We say call this, right? So then this will be true, right? And we have to parse tool input commercial tool use dot input into response. Okay, so this is some work that we have to do, right? So generate structured response for Anthropic is done. This looks good. So the caveat here being that it Anthropic does not provide a response schema in its API. So we are forced to use tool definition to generate that, right? Yeah. Let's get it over with for Google and then we can move forward. Right. So we had done this implement, right? So we'll copy all of this and right. So here we don't need tools. Tools is gone. Right. We need response schema, right? Here we reuse our generate Google schema for our instances. That is always require error or return error. Here we are hard coding this. Right. Now what we have to do here is get the content and JSON unmarshal unmarshal the content to rest. Error, we just bail here. pass it as a byte array. See what happens. This is content dot part dot zero dot text. So, this one. Okay. This bit unsafe actually, so I'm not comfortable with all of this. So I will say if length of this is greater than 0, end with else return error. Right, so I'll let the caller figure out why this happened. Right. Okay, I think we have done. Okay, I thought the stream was offline. My bad. Okay, the stream is healthy. People are watching. Okay. Okay, let's continue. So let's not spend time. What we wanted to do was do token counting, and this is you're doing this primarily because we want to know how much our agentic session is costing, right? So I have compiled this Google Sheet to capture the cost of models from the different providers, right? I have captured Anthropic, Cloud Models, OpenAI, GPT, Google Gemini. I also captured DeepSeek, which we have not integrated yet, but we will soon. So I just prepared upfront. So given the cost, so if you take an overview of this, so these are the frontier models from Claude, which is 4.5 models, Opus, Sonnet, and Haiku. From GPT, which is GPT 5, 5.2 Pro, Mini Nano, normal one, and Pro. From Google, Google 3 Pro and Google 3 Flash. So these are the like frontier model. For now, we will just bother ourselves with frontier models, right? We will not do this one because anyway they were going to get expired soon, right? So we want to know which model to use for our particular job, right? So one thing obvious is the cost, right? We don't want to be using, let's say, GPT-4. If you see the cost is exorbitant, right? The cost is $21 for a million token in input and $168 for 1 million output tokens, right? This is huge cost, right? I don't think anybody can afford doing agentic coding using this, right? I mean, we might as well get some people to do our coding for, right? So this is, I don't know why they're priced. I think they just want to stand out that their model is the best. I don't know why anybody would use this for now. I mean, at least for this project, it doesn't make sense. But if you see something interesting, the Gemini top models are quite cheap, right? So $2 for input, million input tokens, $12 for output, right? If the context exceeds, then it's $18. So this is quite cost effective. But we would want to know whether these are, doing anything for our agent, right? So one is, so what we have to do is trade off with cost and accuracy, right? So there are some good reviews of Gemini, but we'll see firsthand how it works. So this is also another reason why we have a Git workflow, right? We can try different models, see which one is more accurate before accepting, right? So this we can do it in evaluation phase, not always, but so we also keep this as an option. So one thing we get with Cloud Code is that we have to integrate with Cloud, right? And uh, incur this high cost, right? So one thing with our agent framework is that our agent framework will integrate with uh, all the other models, so we can make a cost decision for a particular task which model to use, right? And later we're going to go into sub agents, right, where our root agent will decide which model to use to do a specific task, right? So all of those complex workflows we can make. So that is why token counting is important. The other thing to notice in this chart is the way caching is done, right? With all these models. So you see, so uh, there are three different ways caching occurs, right? One is the OpenAI way, which DeepSeek also follows, which is that uh, anything more than a particular size input will automatically be cached. The cache will be for 5 minutes minimum, and but if there is no contention is off peak hours, it can extend to 1 hour, right? There's no cost for writes, right? And reading from cache is a bit cheaper, right? So if you see, it's 10% of the actual cost reading from this reading from a particular cache, right? So in our agentic workflow, we are going to heavily use cache, right? Because our conversation history keeps getting bigger, right? So the previous conversation, we will be referencing them from cache and not sending them over and over again, right? So that is why we are going to use cache heavily. So this is one way where OpenAI does caching, which is automatic caching is what you can see. Anthropic has explicit caching, where we have to pass a header saying that, okay, I want to cache this input, right? And then we will incur a cache write cost, right? And it is usually 1.25 times the input token cost, right? So writing into cache is also going to cost us money. And if you want to write for 5 minutes, this is the cost. If we want to write for 1 hour, right, the cost is double, right, of the input token. And if you want to read from cache, it's the same deal. We get 90% off, right? So this is a huge discount on our context window, right? So we are going to heavily use cache here as well. So this is how Anthropic works. Google, on the other hand, has both explicit and implicit, right? So from in the header, we can mention whether we want to do explicit or implicit caching, right? Regarding TTL, it has a different behavior, right? The cache can stay long for a very long time, right? And it uses a storage, right? And we have to pay for the storage cost, right? So this is a bit different behavior than the regular ones. Uh, but we're gonna see, like, so here the extra thing that we have to do is if we write it into cache, we have to delete it, right? Otherwise we would be incurring huge storage cost, right? If we write to cache, we forget about it, we get a huge bill, right? So we would have to handle all of this when we are implementing. But for now, what we are implementing is just uh, calculating the cost of our session, right? So that is the scope of this discussion. Also, this sheet, I'll attach a link to it somewhere so that this is a public sheet. I will attach it in chat so that if you are interested, you can look into it. Pause. That is done. Right. Let's start actually. So because we're a bit behind time, so we have to go on. All right. So what we're going to do actually is uh, let's start with the interface, right? Run, run inference. Actually, here we are going to send back metadata, right, along with this. This metadata will tell a couple of things regarding this session, right? What that would be, right? Metadata. One is what is the cost for this particular session, right? The other is time. How much time the session took, right? So these are the few metadata we'll be uh, capturing because we want our sessions to be a bit more observable, right? And we want to see how much all of these cost, right? Right. So we are sending this in both implementations. Let's start with OpenAI. Should be a bit simpler, and since it has implicit caching, we can maybe even test it in the stream, or else we can continue next. So okay, now how to do cost calculation, right? So in each an inference we will get, even before we see whether error is there or not, we have to see how much it costs, right? So because we might have error plus some costing, so we cannot ignore that. So what we say, open AI cost, right? And what we can give it is this usage object. Now this usage will tell us how much tokens we consume, and based on the pricing that I showed earlier, we have to hard code that pricing in this sheet because there's no API to get those. So we have to hard code it in this code because there's no way to get it from anywhere else. Right? What we have to also give is the model, right? And here we have to give metadata. Maybe we need a metadata because this might be nil in case of error. Let's open types. This is pointer to metadata, pointer to metadata. Oh, this is not here. It's in the response. Okay. So let me put this back here. Right. Right. So cost and time. Open it. Metadata. So all of this has erroring out already. Here there's nothing to analyze. Right here we will send metadata. Cost is cost and time is taken is since now, so we can say time is time taken, right? Okay, I think duration is a good type for this, right? Because in golang this is a very nice way to say, right? So anything happens here, we have to give it these stuff, right? Yeah, then we have to implement this guy, right? It requires a float 64 to be returned. Let's initialize cost. Right. So what is this? Let's accept a string as a model. Right. So we need to create some. We need to create some constants, right? So let's say 1 mil equal to, right? So this is a, because the cost is per million, right? So input to per mil for GPT, let's initialize it to 0 because based on the model it will change, right? So we'll see which models will output per cache read per m 0, right? So initialize to 0, right? Now we will match string has prefix model. If it has prefix GPT 5.2 Pro, right? So this is the first model we will check for. So I have the sheet on my left, so I will just add the numbers from the sheet, right? So the cost, as we discussed, for this is $21, exorbitant. Output is $168, and cache rate is it should be 10%, right? So oh, okay, there is another caveat. So this one, so this particular Pro model does not have caching, right? I don't know why. OpenAI decided that, okay, Pro models won't have caching. If string has 2, right, the regular models, then input per is equal to 1.75. Output is 14. Cache is 10% of that. So I will say. So we'll be integrating with like a select models, right? Will not support all, and this will be guided by what are the frontier models, right? So we will also do ChatGPT 5 mini, right? Which should be cheaper for some operations. As you can see, it's 1.25. Output cost is still expensive, $10, and should be 25. Yeah. Nano. Now this is the cheapest model I found anywhere. I don't know what it can do, what it cannot do. We will figure it out when we do some evaluation. But this is 0.05, right? And output is 0.4. So this is the cheapest model of all the models out there. And maybe it is DeepSeek, not considering that, but yeah. So we start adding. We add input cost first. Cost, right? Cost plus equal to. Now in the usage, we will already have. Let's convert to float. 64 of usage dot prompt tokens. We had to, what we have to do is remove the cache tokens here, right? So if you see here, this is number of prompt tokens, right? But what we have to do is remove the cache tokens from it, right? So prompt, because it's charged differently, right? So then we multiply this by input n and then divide by 1. So this is how we're going to do calculation. Let's do 1 mil is 0. Let's make it a float. Okay, this. Okay, then add cache reads cost, which is going to be actually the same thing for this guy. And then we have cache read cost. And then add output token cost, which will be the highest. to print here. So here they call it completion tokens, right? And then we return cost. Okay, that's it. That's what this is. That's what I mean by token counting. Every session we do, we have to measure how much token we are consuming, because that is money, and a lot of our decisions in this agent engineering will be creating cost effective agents, right? We don't want to be paying, for this guy to do everything, right? Right. Okay, this can be nil. Okay. Is it? Okay, it can be nil. This can pass a nil. So let's do it out. In this case, this is nil. We have nothing to infer cost from. Okay. We are on track to finishing this, right? So we are sending back the metadata. Okay. Let's do it in generate structured response as well, right? Because here also cost is important. What we do is here we changed to send dot metadata nil, nil, nil. There will be no cost before this, but as soon as we compute, so now we have hard coded the model, but all this stuff will have different kinds of models for different operations that we're doing. Dot usage, right? And then we need to do time. Okay, here we have to send metadata, right? Because this has already cost us money, cost and time. Right. Let's copy this. Send it here. If it does not give us proper JSON, that is fine, but already cost money. Okay, so this implementation for OpenAI is done. Let's quickly go through Anthropic and Google. So this is a bit painful to do repeatedly, but in next stream when we integrate with DeepSeek, the cost will be lower, and also we will integrate with a local model Quen 2.5, right? So for that the cost will be zero. Only there will be a time cost, right? So when we do our agent orchestration, then we can see what jobs we can offload to Quen 2.5 and what jobs we a higher model needs to do, right? So this is why we are spending so much time here. So all of this is going to be fruitful a bit later on. So we power through it, right? Yeah, right. So again, we have to do here is compute Anthropic cost. We send it this dot usage. Again, also I have to send it a model string, right? And once we have this, it is here. Right. Okay. This needs to be implemented, but this is fine. There is what an inference. The main function. Okay, it's here. In metadata. Right. Maybe here. Okay, here we already do the cost counting, compute, anthropic cost. We pass. So if you're wondering why we are not using any agent to do this is we don't want any current agents like Cloud Code to influence how we're building our agent, right? So we want to build this from scratch. So when our agent itself is a bit mature, we will use our coding agent to build the framework as well, right? For now, we're just doing it manually. Quick response usage. Metadata, cost, time. Nice. Okay, I think we have this and Google left, and then we should be done for the day. So I think last 10 minutes we should be good. Okay, so same thing here. What we do is, let me open the sheet. Anthropic. So let me just copy from the initial variable. The string is model has, so Opus, right? So Opus 4.5 is the best model out there, right? So it's also expensive, but one thing to notice. Okay, I'll get to that a bit later. Let's finish this so we can have some discussion, right? So for the input per is 5, right? Output is 25. Cache, if we create for 6, if we create for 5 minutes, it's this. If we create for 1 hour, it's twice that. Cache read is, how much is it? 10%, which is 0.5, right? So we'll integrate with 3 model. Opus. So here there is a caveat, right? As we see, if the usage dot input tokens is greater than equal to 200k, the cost is a bit different, right? If it is greater, then input becomes 6. Output is 22.5. Cache create is 3.5. Per hour is 12, and read is 0.6. So this is a bit more expensive if our context window exceeds this, right? If it's within, it's half the price, right? Output is 15. Cache create for this is 7.5. Cache this is 12. Cache rate is 0.3. Should be 0.3, right? And so this is for Sonnet. The other model we will integrate with is if strings haiku. Right now, haiku is a bit cheaper. One output is 5. Cache create per minute 1.25. 1.25. Right now we add all costs plus 64 of usage, input token minus usage, cache read input token into input per, right, plus equal. Then we add a read. Which is this. Just read tokens. Then we have two costs, right? Right for cache create and cache create 1 hour, and the place to find it is in cache creation ephemeral 5-minute input, cache creation ephemeral 1 hour. So this is all the cost for. We are not using output anywhere. Okay, that is the highest cost. Plus is equal to this guy. Output, what is it? I cannot cache creation. Output tokens. Right. Okay. This is for okay. One last thing is remaining is for Google. Let me wrap this up. Usage metadata. Okay. Doing it with Let me do this for this guy as well. Run inference. Where is it? Okay, this is the last thing remaining. Token is greater than equal to 20,000. Input per is 4. Output per is 18. Cash per is else input per is 2. Output is 12. Cash is 0.2. Else if it's flash. Okay, flash does not have more than 2000 context, so input per m is 2, output per m is 12. Okay, now we'll do the same thing here. Cost plus equal to float metadata dot prompt tokens minus metadata dot cached prompt tokens into input by 1. So we do this input, output, and cache. So this is cache read. This is put candidate tokens. Return. Okay, fine. We're done. Okay, so here everywhere we have to have metadata, right? Session. Okay. Agent is saying inference cost, right? Printf cost is equal to f. I think decimal cost is this, and right here we maintain total cost. Yeah, loop. We say this is for loop cost is this cost total duration count. We do the same thing at the end of the session. Okay. Okay, I think so we've done with all the stuff. Let's test it once and then we can uh, let's test it once and then we can call it a day, right? Let's ask another question. What are the frameworks libraries in JS and Go for chess, right? Let's use OpenAI and let's see if it prints out cost. Then we can call it a day. Okay. Problem. Oh, sorry, wrong. Okay, I think okay. Anyway, so basically it's saying that it added an answer and it also is printing the session cost for this. So I think this is a good place to call it a day. Also, I'm getting that the stream quality is poor. I don't know why. But yeah, I think this is quite good progress for one day. We're a bit over time as well. So thanks everyone for joining and see you folks next week. Thanks.